Thank you everybody for coming to the first meeting of the year for the Astronomy Fundamentals group. I see a bunch of names that are new to the group. So to kind of give an idea of how this meeting normally goes, we have two presentations that are normally given. First is a constellation, or in tonight's case, constellations of the month. If you're joining this meeting from the invite, you'll see that I mentioned that there wasn't any, but shortly after I sent out that notice, I was contacted by Doug, who offered two constellations for the month. So we will have that. He will be doing Doug Octans, and what else?
I'm doing Grus and Pictor.
Grus and Pictor. I don't know why I thought you were doing Octans. So, and then after that, Peter Hermes will be doing the main topic, which is on asterisms. Excuse me, I'm jumping to a case current astronomical lead project, but the asterisms also tie into an astronomical league program where
or asterisms.
Asterisms. So for those who do not know what the Astronomical League is, it is a secondary organization that has a whole bunch of programs or things to do in the night sky. Where they give you a list of things to go observe or an activity to go do. You go do it, you turn it in, you get a certificate and a pin usually, or a couple of other things. And Doug is our resident coordinator for that. So if you do have questions about the Astronomical League, please contact Doug Smith in the chat. Doug, is there another email to reach you at through the club?
Yeah, there's you can send to the Astronomical League coordinator email, or just send it to me directly. dsmith217@cox.net.
Cool, thank you. And with that, I will also add, we are always looking for people to present at this meeting. I am currently back in school for pursuing my master's, so it's when it's the school season, it's usually very difficult for me to fill in as a presenter. So anyone who is willing to volunteer as a presenter, please reach out to me. If you're interested but don't know what to do, we've had some suggestions during a couple of our previous meetings about some things that members would like to see. So if you're interested in learning about various astronomy topics and then presenting that to others, by all means, please reach out to me. Don't worry about being super fancy or formal with it. Have fun with it. Learn something. That's kind of the idea, and share it with the rest of us. And with introductions and the preamble out of the way, Doug, I need to make you a co-host so you can present. Co-host. Yes. And we will go ahead and get started.
All right.
Whenever you are ready, Doug, you should have co-host now.
Share my screen here.
And Peter, as you have it as well for when it's time for you.
Got it, thanks.
Okay. Let's put it in.
So one of your scopes, Doug?
Okay. No.
That looks like the 9-inch out at CAC, or is that something at the Texas Star Party?
I've been using that picture on a lot of my presentations as a starting point. So tonight I'm going to cover the constellations Grus and Pictor, which are both in the southern hemisphere. Okay, that's nice. Okay. I always like to start off with a little bit of humor. So this one I found online. If computers were around and Galileo did his thing at the Tower of Pisa, he would have been throwing them out. I agree. Okay, so get rid of that little bar. Okay, there we go. Okay, so Grus constellation of the southern sky. It's an average size constellation. It ranks 45 out of the 88 constellations in terms of area that it covers in the sky. Covers maybe 15 degrees in declination and about 2 hours in right ascension. It's bordered by Sculptor, Pisces Austrinus, Microscopium, Indus, Tucana, and Phoenix, which are constellations probably we've never looked at. They're all in the southern sky. Oh, Sculptor. I've seen something in Sculptor. Grus can actually be seen from Tucson. The best time to view it would be September or October when it's due south in the early evening. And you can actually see the entire constellation. It'll get just barely above the horizon. The stars that form Grus were originally part of the neighboring of the constellation Pisces Austrinus. Gamma Grus was actually in the fishtail. The stars were first defined as a separate constellation by the Dutch astronomer Petrus Plancius, who he created 12 new constellations in the southern sky based on observations by a couple of Dutch explorers, Peter Dukezoom and Dukezoom Kaiser and Frederick de Houtman, who had sailed to the Dutch East Indies in the, I think it was the 1580s. The first time we saw Grus in an actual star atlas was in Johann Bayer's Uranometria, which was published in 1603. Houtman included it in his southern catalog same year, but he called it the Heron, but Bayer called it Grus. And this is a picture out of Uranometria, and the red box shows Grus. Grus is actually an easy constellation to see because it has several bright stars. There's like, I think 3 or 4 stars that are all greater than magnitude 3. So it's not too hard to find if you can look that far south. And even though it's like 90 degrees away from the Milky Way, it's actually pretty rich in stars. There are 13 stars brighter than magnitude 5 and over 50 stars greater than magnitude 7. So if you were in a dark location like in Australia, you could see a lot of stars in this constellation. The brightest star in the constellation is Alpha Grus. It's named L-Nair. It's a blue-white star, spectral type B6V, and it's got a magnitude of 1.7, so it's pretty bright. It's around 100 light years from the Earth. It's 380 times as luminous as the sun and has 3 times the diameter of the sun. And it's circled there on the right there, Alpha, L-Nair. 5 degrees west of L-Nair is Beta Grus. Oh, Grus? Oops. It has a name. It's called Tiaki. It's a red giant, spectral type M5. It has a diameter about 0.8 astronomical units. So it's a really big star. If you put it in the solar system, it would be as large as the orbit of Venus. So it's a massive star in terms of size. It's located about 170 light years away. It's a variable star that goes back and forth between magnitude 2 and 2.3. And it's circled there on the left. Up in the corner of the constellation and marking what's called the crane's eye. Grus is a heron or a crane. It's a bird. If you remember the picture here, it's a bird. And the eye of the bird is this star up here in the corner, Gamma Grus. And I did Grus again with an eye. Shame on me. It's a blue-white subgiant of spectral type B8 in its magnitude 3. It's 211 light years from the Earth. And it's got a name, El Denab. It's no longer fusing hydrogen in its core, and it's cooling. And eventually we'll see it transform into a red giant. And then there's a couple of naked eye double stars in Grus. The one that I got marked there is Delta Grus. It's an optical double, Delta 1 and Delta 2, separated by about 45 arc seconds. Delta 1 is a yellow giant, spectral type G7, magnitude 4. It probably has a magnitude 12 dwarf companion that's orange. And then Delta 2 is a red giant, a spectral type M4.5. And it's a semi-regular variable that changes its magnitude between 3.99 and 4.2, which isn't much of a change. It's located 325 light years, got 3 times the mass and 135 times the diameter of our sun. And then the last interesting star is Mu Grus. I'm a bad typist. That's composed of 2 components, Mu1 and Mu2. Both stars are yellow giants. They're both about 2.5 times as massive as the sun. Temperature is about 4,900 Kelvin. Mu is slightly brighter at 4.8, while Mu2 is at 5.1. And they're both about, Mu1 is 275 and Mu2 is 265 light years distance. So, okay, that's it for the bright stars. Now, like I said before, Grus is like 90 degrees off the galactic plane. Usually when there's a constellation that's that far off the galactic plane, there's usually quite a few deep sky objects in it because you're not looking through the dust and gas that's in the Milky Way. You usually have a pretty clear view of objects out there in the deep sky. But Grus is pretty poor. There isn't much there. Maybe that's because it's a small constellation, I don't know. But there isn't a lot there to look at. There are a few objects. This one, IC 5148, the IC stands for the Index Catalog. It's called the Spare Tire Nebula. It's a really pretty planetary nebula, like if you see the picture there. That's a nice Hubble picture, but it's not very bright, magnitude 16.5. You'd need a pretty good sized telescope to see it. It's 3,000 light years from the Earth, and it's right in the middle of that red circle. There is one thing in Grus that's rather interesting. There's what's called the Grus Quartet. It's a cluster of 4 galaxies that are all gravitationally interacting with each other. NGC 7599, 7590, 7582, and 7552. All 4 of them are spiral galaxies. There's a hydrogen 1 bridge running between 7552 and 7582. You probably can't see the bridge with any kind of moderate telescope. You probably need a big telescope or a radio telescope to see it, but it's there. The entire cluster is about 60 million light years from Earth. All of the galaxies are around magnitude 11.2, so you could see them in a modest telescope. And the picture on the top shows 3 of them, 82, 90, and 99, and then 7552 is in this picture on the bottom. and it's more or less in the correct position. But I couldn't find a picture of the entire cluster. But it's located right there in the middle of that red circle. And this is a nice, pretty galaxy. This is a nice barred spiral galaxy, 7424. It's got a magnitude of 10.4, so it would be visible in like an 8-inch telescope or maybe even a 6-inch. It's located 4 degrees to the west of that Grus quartet triplet that I just showed you. It's 37.5 million light years away, and it's about 100,000 light years in diameter. It has very nice defined spiral arms, and it's thought to pretty much be like almost a twin, very similar to the Milky Way. 2 very bright X-ray sources and a supernova have been observed in this galaxy recently, and it's located in the circle. And that's it for Grus. Any questions on Grus?
I take it the X-ray sources observed were black holes or
I
neutron star?
honestly, I don't know. All I could find is it said 2 ultraluminous X-ray sources have been observed in the galaxy. I don't know. It would be probably pretty safe to assume at least one of them is the black hole. I don't know what the second one would be.
Usually it would be when it comes to X-ray sources, are either a black hole, a pulsar, or a neutron star interacting with something else.
My guess is one of them is the black hole that's at the center of the galaxy, and the second one is, like Connor said, one of the other objects in the neutron star or a pulsar or something like that. I couldn't find out much information about them. Okay, I'll move on to Pictor now. So Pictor is another constellation in the southern sky. It's actually very small. It ranks 59 out of the 88 constellations. Covers maybe, if you think about it, maybe 15 degrees in declination and probably only 1.2, 1.5 hours in right ascension, depending on how you measure it. And it's bordered by some other southern constellations: Puppis, Columba, Calum, Dorado, Volans, and Carino. And Pictor can be seen partially from Tucson. We can see things in Tucson down to about -58 degrees. So we can see most of Pictor, but not all of it. Basically, if you can see the bright star Canopus, which is that giant black dot in the middle of the picture there, then you can see Pictor, or at least half of Pictor. And it's an easy way to find Pictor if you're ever in the southern hemispheres. Find Canopus, and Pictor is right next to it. And the best time to see Pictor is like February and March. And so French astronomer Louis de la Caille first described Pictor as La Chevelette, La Palette, otherwise translated the easel and the palette. In 1756, he cataloged about 10,000 southern stars during a 2-year stay at the Cape of Good Hope. He devised 14 constellations in the southern sky, not visible from Europe. All but one honored instruments that symbolize the Age of Enlightenment. Like you've got octants, and there's all these other constellations that are named after instruments. And this one's named after easel and palette. I guess that's an instrument of enlightenment, sort of. He gave the constellations Bayer designations, meaning he named the stars Alpha, Beta, etc., Alpha Pictor, Beta Pictor, etc., all the way down to Nu Pictoris, which is number 10, the 10th brightest star. He labeled the constellation Equus Pictoris in his 1763 chart, which is what you're looking at right there, meaning a small horse or easel, etc. Because they used to carry canvas on a donkey. Artists did that. The German astronomer Bode called it Palladium Pictoris, and the name was shortened in 1845 to just Pictor on the suggestion of John Herschel. So that's Pictor, and there's Canopus there. Pictor is a pretty faint constellation. The three brightest stars can be seen near Canopus, and there are 49 stars brighter than magnitude 6.5 in the constellation. But the brightest star in Pictor, Alpha Pictoris, which is 97 light years from the Earth, is only magnitude 3.3, not terribly bright. It's a spectral type A8, so I think that's a blue giant, right? It's a rapidly spinning star, and it's got a rotational velocity of 200 kilometers per second, and it has a shell of circumstellar gas around it that's been measured. Beta Pictor, which is the other circled star there, it's also spectral type A6. So I guess that's a white star, right? White main sequence, yeah. It has an apparent magnitude of 3.86. So we're not talking about bright stars here. It's located 63 light years. It's a member of a group of stars. There's a group of 17 stars that are approximately 12 million years old. They're all moving through space together, which sort of implies that they were probably all formed out of the same cloud of gas. And so they're all common motion in the same direction and all roughly the same age. Beta Pictor is actually a very interesting star. Yeah, it was the first star that was actually discovered to have what's called a debris disk around it. And since that discovery in 1984, they've discovered an exoplanet about 8 times the mass of Jupiter that's orbiting about 8 astronomical units away from the star, which is similar distance between Sun and Saturn. And the European Southern Observatory actually confirmed this with direct imaging from the Very Large Telescope in 2009. There's Gamma Pictor, which is down in the bottom circle there. It's an orange giant, spectral type K. It's about 1.4 times the diameter of the sun, has an apparent magnitude of 4.5, lies 174 light years away. And then Delta Pictor is an eclipsing binary. It's about 1,300 light years from Earth, and it's composed of 2 blue stars, spectral types B3 and O9. It has a period of 1.67 days, and it dips from apparent magnitude 4.65 down to 4.9. And the stars are so close together that they're oval shaped. They are gravitationally distorting each other. So that's a very interesting system. And then LaSalle named 2 neighboring stars, Eta 1 Pictor and Eta 2 Pictor. And Eta 2 Pictor is an orange giant, apparent magnitude 5, and it's 474 light years away. It's about 5.5 times the size of the sun. And Eta 1 Pictor is 85 light years away. Main sequence star F5 with a magnitude of 5.38. And it's a double star, and it has a companion of magnitude 13. And the 2 stars are separated by 11 arc seconds. So that would be a nice double to look at with a telescope. And just like Grus, Pictor is really, really very poor in deep sky objects. In fact, there are no deep sky objects in Pictor brighter than magnitude 12. So if you had a 6-inch telescope, there's nothing you could see in Pictor in terms of deep sky objects. You'd need a bigger telescope to see any of them. And there aren't many. There's just a couple. There's NGC 1705, which is a blue compact dwarf galaxy. It's real close to Iota Pictoris in that red circle there. And it's undergoing major starburst activity. And in the image there, that's the image there, you can see the starburst activity on the right side there, that big bright area. But it's at magnitude 12.6, so you probably need at least an 8-inch to see it. It's approximately 17 million light years from the Earth and is a member of what's called the Dorado group of galaxies. Then there's Pictor A, which is about 485 million light years. It's a double lobe broadline radio galaxy, powerful radio source in the southern hemisphere. Contains a supermassive black hole, and it's got a relativistic jet that's shooting out to an X-ray hotspot. The visible component, which the image on the left there is a combination of the visible and the X-ray radio, sorry, the radio telescope image. The visible component are just the two bright white dots, as all you would see if you looked at it through a telescope. It's only got a magnitude of 15.8, so you probably can't see it. But it would, if you did want to go looking for it in the southern hemisphere, the red circle shows you where it is. And then there's GRB. There was a gamma ray burster observed on the 29th of July in 2006. It is believed that it was a type 1c supernova, the core collapse of a massive star. It was notable because it had an afterglow in X-rays that lasted 642 days after the original burst. And the object that caused it was very remote, some remote something somewhere. With a redshift of 0.54. Pardon me, my auto security stuff just popped up. There we go. Sorry about that. There's nothing much there to see now, but it's located down in that lower red circle. And I think that is my last slide. Yep, it is. That. This. Any questions on Pictor?
Yeah, Doug, this is Pete. Going back to your last slide there, dealing with the gamma ray burst. I understand it was primarily a gamma ray burst, but being that it was the collapse of a massive star, there must have been an optical component. Was it just too far to see from any
I think
scopes here?
it's just too far away. I don't even think
Okay.
it's located in our galaxy. I mean,
Oh, okay, I got you.
it's got a redshift of 0.54, which
Yeah,
means
I noticed that,
probably-
which is pretty significant. So it's rapidly moving away. So,
it's
okay,
it's somewhere else in the universe.
yeah, thank you.
Any additional questions? All right, I'm going to stop sharing my screen. There we are.
Thank you very much, Doug. So since we do have a lot of new members as well tonight, which is always a good thing to see, you may have seen a lot of terms you may not be familiar with introduced in this presentation. We do have an archive of presentations that actually do explain many of the terms from right ascension and declination to apparent magnitude. So if you are interested in accessing them, please reply to the email where you got the Zoom meeting from, the fundamentals@astronomy.com, and I can send you the links to the archives. I do not include those because I don't want those winding up outside the club right now. Okay. So if you, Tom, I see you have your hand raised. Is that an expression of interest in the presentations, or do you have a question?
I have a question. The last galaxy you showed us in Grus, you mentioned it was, well-formed spiral. It looked to me, if I'm not imagining, it looked to me like the arm sort of straightened out the farther away you get. Is that my imagination, or do we have any idea why that's a little different than the nice, curvy spiral arms?
That, if I may, Doug, that
ahead.
could be because of dark matter affecting the velocity of the stars around the rim of the galaxy, because they all rotate at a uniform rate due to the effects of dark matter. So some of them would potentially be causing that slight stretching. That would be my best, shot in the dark guess, which may be entirely wrong.
Sounds good.
Yeah, Doug, I had another question regarding your presentation. You talked about, I think it was the second constellation, Pictor. You talked about two stars that are somewhat oblate because they're gravitationally acting on each other.
Yes, they're close enough to where they're deforming each other's shape so that they're not spherical anymore.
Okay, is that something that was measured optically or some other means through the spectrum? Do you know?
I do not know.
Okay. And do you know how close or how far apart they are?
I don't know that either.
Okay, thank you.
You get these tidbits of information online about these stars, but then they don't give you everything.
Oh, I know. To me, that sounds like a pretty rare occurrence.
It is.
Not just in discussing constellations, but stars.
That's actually the
themselves.
first time I've actually heard of that, where they were absolutely, they theorized that that's probably actually fairly common in a lot of close double stars. They're gravitationally interacting with each other. You could have like a white dwarf orbiting a red giant at a very close distance, and it's pulling matter off of you've always heard about that. It pulls.
Yeah, I hear about the matter being pulled, but not so much the
But
deformation.
two stars
of the
that
shape.
are closer together in size, if they're interacting that way, you'd get, teardrop shape on both of them with matter going back and forth between them.
Right.
Theoretically, that's actually fairly common, but this is the first time I've ever seen it where they said, we know this is what's happening. How they know that, I couldn't figure out.
Got it.
Connor, would you have any idea how they would actually know that? Because they stated it in the article I read. It was stated as an absolute fact that they know that these stars are not spherical in shape, that are gravitationally, distorted.
They probably could see something in the one of the other in some form of EM spectrum and then simulate it on a computer. That would be one potential way to see it.
You think maybe they're getting that off of spectrums?
No. So they saw something funny in an observation of that star, and then they decided to simulate that environment on the computer because they couldn't make out what they were seeing. That's one way I could see it. But I'm not sure if that would be the case. I'm not quite sure what I'm not quite sure you could use anything in terms of a light shift because you're not seeing an accretion disk, or you couldn't see like one side of the star coming towards you. So I'm not sure how you would see the deformation like that. Unless it was
radial velocity, maybe, as the stars rotate around each other. You might see more radial velocity on one side than the other for some reason. I don't know.
Maybe.
I'm guessing.
I don't think radial velocity would be a good way to see that because you're really looking at how a star's gets tugged around.
I would have to.
Yeah, you might.
The article I read stated it quite factually, and then gave a bunch of references to articles published in like the Astrophysical Journal and stuff like that. I would have to go into those references to see how they made those determinations.
So yeah, you might be right with radial velocity, but it might also have been done by computer simulation after observing something on the stars. Those would be my two most likely guesses.
Yeah, and I don't go that deep into the research for this type of presentation.
Excellent questions. And with that, we will shift over to Pete Hermes for the main topic on asterisms. So Pete, take it away. And you are also muted, by the way.
Sorry. I was trying to get my mouse to go. Oh, there I see. Got too many screens up. How's that? You see the presentation? Okay. At least the first page, it says asterisms.
Yes.
Okay, very good. First off, Doug, thanks for the presentation on the two constellations, and group, thank you for tuning in on this presentation on asterisms. A couple of things that I'll be covering tonight, basically definition and background. What are asterisms? How did they come about? For the most part, my presentation is pretty holistic. I'm going to stay at a pretty high level. I'll get into a few examples, but there aren't a lot of them. I'll discuss those, a little bit of the historical context. And like I say, examples, looking at asterisms that are primarily naked eye types, constellation-based, binocular, and telescopic. I'll talk a little bit about the sources. There aren't a whole lot of sources. And for the most part, when you talk about constellations, which prior to 1928, there were constellations, but everything was basically an asterism. After 1928, when the 88 constellations were officially recognized, specified, and then reported 2 years later, then there became a greater differentiation between asterisms and constellations. And one thing too, I'll note for most of the images, and by all means, if someone sees something differently, please call to my attention. But for the most part, with respect to charts, north should generally be up in the images, with west off to the right side or clockwise as we go through some of the images. And by all means, if I mispronounce something, please pipe in, or if you've got some other additional information, I'll probably stop, especially when I start talking about the examples, and ask the group if anyone has any special one that they want to bring to attention. Okay, going basically into the definition, group of stars, in observational astronomy is defined as an asterism. Here again, differentiating between constellations after 1928. And basically, so prior to then, there was really an asterism was any pattern of stars in the sky. Some of those patterns can be relatively simple, clearly identifiable shapes, maybe just 2 or 3 stars. Some of them can be rather complex and cover wide areas of the sky. Here again, I'll look at a classification primarily because, and one of the things I will talk about when I talk about sources at the end is making reference to something we talked about a little bit earlier, but the Astronomical League does have an observing program that focuses on asterisms. And so, I'll just segue and close with that. But anyhow, that's basically the way the Astronomical League's program on asterism observations conducted. You have naked eye, binocular, and telescopic. Larger and brighter asterisms, of course, are good patterns for learning the night sky, just like some of the more popular or more recognizable constellations are. In some cases, some of the asterisms may be physically associated. For instance, 5 of the stars in the Big Dipper, excluding the 2 at the extremis, I think it's Alkaid and Dubhe, are moving in a common fashion, and so possibly may have originated from a common source. But then there are, and this is referred to as the Ursa Major moving group. I think the same thing also applies to the Belt and Orion, the OB1 moving group. And then you have unrelated stars, which is what most asterisms are. And you look at something like the Summer Triangle, which is very large, and in this case goes across multiple constellations and a fair, amount of area or territory in the sky, as that's comprised of Deneb, Altair, and Vega. Making reference again here to the 88 officially recognized constellations by the International Astronomical League, which took place in 1928, and that's where we get the differentiation. Prior to that, basically, yeah, you may have used the term constellation, but basically everything was an asterism because it was unofficial. There were no recognized boundaries, and that's one of the things that you can differentiate between constellations and asterisms today. Asterisms don't have boundaries, whereas the constellations do, and they're laid out in the charts laid out by the IAU. Throughout history, different peoples and cultures have used different methods and had different interpretations of what the sky was showing them, both in, whether or not it was the figure of a mythical being, a person, an animal, something along these lines. And here again, no distinct differences between a constellation and asterism until the official recognition of constellations in 1928. And here again, what's the clear differentiation? Define boundaries. For the most part, asterisms and constellations both, are connected point figures. We know certainly we look at the zodiac, where we have a number of mythical beings and animals, with the exception of one, Libra, out of all the zodiac signs. And then, of course, a large number of the other constellations and asterisms will also identify, similar objects. They could be animals, they could be a letter, they could be some, common object in the sky. And I will tell you, as we get into, especially when we get into some of the examples, you'll find that some are fairly obvious, some not so much. Going back a little bit, one thing too, in some of these patterns, you take a look at specific constellations like Orion and Scorpius. They've pretty much, been, recognized by various cultures for millennia. These are probably two of the oldest and two of the most common recognized. And of course, a lot of the zodiac constellations you can probably say the same thing about. But as far as patterns in the sky being put into a compendium or being, noted by, some of the more advanced cultures, we have the case of the natural history that was compiled by Pliny the Elder, who was a Roman author, naturalist, philosopher, and military commander. He comprised an encyclopedia that had 10 volumes. Within those 10 volumes, there were 37 books. And one of those books in volume 1 had 72 asterisms in it. And I would imagine they were probably diagrammed out. The stars weren't necessarily named, but it was more so identifying the patterns. And of course, I'm sure that the patterns were named. Similarly, Hipparchus of Nicaea and Ptolemy of Alexandria were likely responsible for designating the bulk of the 48 classical constellations, which were pretty much standard for almost 2 millennia, for 18 centuries. And ultimately those comprised the bulk of the northern constellations that were officially recognized by the IAU, with modifications. And of course, here again, not just the patterns or the figures, but more so the boundaries of those various constellations. Another big, probably seminal point in identifying patterns in the sky, of course, is when the Europeans started leaving their continent, since they had, were compiling most of the information, some of these atlases, some of these compendium on the various patterns in the sky. So when they start to, leave the continent and go out and explore during the 16th and 17th centuries, and had an opportunity to see more patterns in the sky, i.e. going into the southern hemisphere. For the most part, those were within the purview of the indigenous populations there, and weren't really communicated to anybody else, considering that, Europe was probably the center of the most advanced civilizations in the country at the time, in the world at that time, especially with respect to the ability to being able to publish this information, printing, and being able to spread that information on paper throughout the rest of the continent. Additional constellations were specified, and this is something Doug made mention of in his presentation, because certainly he covered 2 southern constellations, but Johann Bahr and Nikolai Louis de la Caille were responsible for specifying, cataloging, designing, making out the constellations, most of the constellations that were in the southern hemisphere, and of course were ultimately accepted by the IAU. Here again, coming back to the IAU, looking at the designation of the 88 constellations, no longer was it ambiguous with respect to the constellations. However, there's still a lot of ambiguity with respect to asterisms because they aren't officially recognized. There is really no standard for asterisms, and that's something you'll see when I start talking about some of the different examples and some of the sources that are available for those. Culturally, some cultural and historical context too. You taking a look at Australia, the Aborigines, the indigenous population in Australia, were probably some of the first astronomers. I think they put a lot of value, a lot of stock in the patterns that were in the sky. which supported basically their storytelling and folklore. And you can see there was actually one pattern, Jopan, three brothers in the canoe, and which is essentially Orion. A little bit different. Of course, not all the stars are identified, but you can see the three brothers in the canoe, the three brothers being represented by the three stars that are in the belt of Orion. And so typically that's how a lot of the Aboriginal patterns were developed. They were used in storytelling and folklore and were passed, from generation to generation. And taking a little bit of a sidelight here with respect to cultural and cultural differences, and it isn't just cultural, but there's a certain branch of astronomy or a specialty of study, archaeoastronomy, which relates the sky to culture, alignments, artifacts, art, and calendars in different cultures. Because of course, prior to the previous century, a lot of these patterns in the sky had differences depending on what part of the world you were in. And of course, some of those things were adopted, some of the names were adopted. Not entirely, and most of it is based on what was developed in Europe in the previous couple of centuries. But this is an important part of the culture of some of these indigenous people, especially with respect to Meso and South America, Australia, because there's a little bit of a record to take a look back, looking at how some of the objects in the sky, and it wasn't necessarily just asterisms, either constellations, but other objects in the sky were used to delve alignments, to develop calendars, drove some of the architecture and actually the positioning of some objects on the ground that were actually moved, some stoneworks that were conducted by various groups. But going back into some of the other ones, Chinese, in the early part of probably the early part of the second millennium, in the Common Era, with respect to their specification, they had constellations and asterisms. Of course, the name doesn't, or the terminology doesn't translate exactly, but basically they took the sky, and here again, two things to keep in mind. They basically broke the sky up into polar regions and into equatorial regions. So two areas that they looked at. And here again, the divisions, their patterns that were documented and passed from generation to generation weren't necessarily in the provenance or the responsibility of astronomers, scholars, or scientific or religious people. They were pretty much in the provenance or recorded by the state or whichever bureaucratic entity existed, in that area. But basically, the Chinese broke the sky up into four groups or symbols, which were, and you can see an example here is the Azure Dragon of the East. They were either mythical beasts, or real beasts. And of course, they associate color and they associate direction with them. Each one of these four groups had what they refer to as 28 mansions or houses. And, as an example, and I didn't list them all, but they may describe a certain portion of that symbol, not necessarily the whole symbol, but certain portions of that. And then contained within those four groups, 28 mansions, we worked down to where, and their groupings were rather small. They had about 283 asterisms identified that were comprised of 1,565 stars. And like I say, for the most part, their groupings, their patterns were much smaller than the Greek, Roman, and European groupings that we've typically come to know. And of course, we know that in, the European, Greek, and Roman patterns, we see all sorts of sizes. There's no one set size. There's no standard with respect to size. We see some very large constellations or asterisms, and we see some very small ones too. And of course, also in the Central Asian portion of the continent, the nakshatra, Hindu and Indian regions, they specified somewhat similar to the Chinese. They had 28 lunar mansions, in some cases 27, of the sky that were associated with these various asterisms. The diagram you see on the right of this one slide, and it's kind of busy, but basically this shows two of the Chinese charts that were used. It would be necessary to go into the source and take a detailed look at them to try to delve out what what some of these symbols may be, or these patterns may show in modern times. So I want to make sure. Okay, now we get into some of the examples. One of the first I'll cover are the large or the bright asterism examples. Generally, not in all cases, but for the most part, most asterisms, unlike constellations, you're going to see groupings that have similar magnitude. Sometimes it's a magnitude range, but a good example of that is, the Great Diamond. I think these are all, I'm not positive in this, but they're either 1 or 2 magnitude stars. The Great Diamond, a couple of major stars from different constellations, Corcoroli, Denebola, Spica, and Arcturus, and they're from, 4 distinct constellations. But this is a very common and recognizable pattern in the sky. I think most folks are probably familiar with it. Currently, it's in our southeast in the early morning, up until about sunrise. I think it's gradually moving closer and closer to the south. But right now, it's not very high. Another very common one that's large and covers multiple constellations is the Winter Triangle. And this is Sirius, Betelgeuse, Procyon. Now, in this case, they're all first magnitude stars. And like I say, generally, this is very typical in a lot of asterisms. And in this case, and you can pretty much see if you look at this particular picture, of course, you can see Betelgeuse sitting at the one corner of Orion. And of course, it really helps that it's kind of red colored in this particular picture. And of course, there's Sirius and then Procyon up to the upper left. And of course, like I say, this is pretty high in the sky during the northern winter. A couple of other large, probably one of the most common ones during the summer, very recognizable, is the Summer Triangle, Altar, Deneb, and Vega. Pretty much overhead for us, I think, during the middle of the summer. Here again, these are all first magnitude stars. It's in the band of the Milky Way, so it's a pretty busy area. And for the most part, when you look down towards Altar, not quite, it's a little off-centered, but basically, the Milky Way band is, running from the top down through the bottom. When you get a little bit south of Aquila, over to the right side a little bit, you end up at the galactic center. For the most part, this asterism has been fairly well recognized and somewhat documented. Ray and Moore in the middle part of the last century had documented it. A guy by the name of Thomas in the early part of the century. And then we can go back to some identification back into the 1800s. And there's believed to be some reference to this in Chinese legend 600 years before the Common Era, or BC. So this is rather an older asterism that's been recognized, and there is some documentation of this. Similarly, when you look at the Great Square of Pegasus, which, if you take a look at Pegasus, you have the 4 main stars that delineate the 4 corners. It's not quite a perfect square. It's referred to more so as an equilateral because it is. I think it is equal length on 2 of the sides, but of course you can see there's a little bit of a slant to it. The one diagram you see here is an easy way to find it if you're not familiar with it, but it's hard to believe one couldn't readily find this. But going from Polaris and going through CAF, one would end up right in the middle of the Great Square of Pegasus. But this is a very common one. Here again, similar magnitudes, large portion of the sky. Others that are similar in nature to this, as far as being large or bright asterisms that cover multiple constellations, also include the Winter Hexagon. There's a Winter Triangle and the Lightning Bolt. Now we're moving into, here again, these are still fairly bright asterisms. And a lot of these are based on constellations, and probably one of the most common, one that most of us, I certainly did, learned first when I was in elementary school. Of course, we didn't know what Ursa Major was or what the Big Bear was, but I certainly knew what the Big Dipper was first, and came to find out later it could, was contained within a constellation. And in this case, we have an asterism, the Big Dipper, which is really part of an entire constellation. Not all of it, only 7 of the stars are specified in this case. In the case of over to the UK, England, or Ireland, they have a different reference to it. They call it the Plough or Charles's Wain. But anyhow, it's the 7 brightest stars in the constellation. We certainly know that there are, Ursa Major is one of the largest constellations in the northern sky, and there's a considerably greater number of stars that are contained within the constellation that are at least above probably magnitude 9 or brighter. Another very common asterism that is part of a constellation is the Northern Cross. In this case, it incorporates probably the 4 brighter points in the constellation Cygnus. both Deneb and Alberio, and then of course Epsilon and Delta Cygni. Now in this case, you can see that it doesn't include the points all the way out to the very ends of the wings, but rather just those midpoints, Epsilon and Delta being here, and of course Deneb and Alberio down at the bottom. And that's the Northern Cross. There is similarly a Southern Cross, and I'll get to that one in a moment. But here we have cases, and there are more, where we have a major asterism that's well recognized, probably very well known by a lot of people, more so than learning the constellations, which are parts of a constellation. Some other constellation-based asterisms, the Southern Cross, I made reference to that. In this case, you have an asterism that basically includes just the, pretty much the entire constellation. Now you see there's a few other stars, but for the most part, when you look at Crux, there's 4 stars. Yeah, okay, there's an Epsilon, and there's probably a few others that may have been given some reference name. But for the most part, here, the asterism and the constellation, this is, because of the small size of this particular constellation, are basically similar, one and the same. Another asterism that is basically a portion of a constellation, but probably the most recognized portion of it is the teapot, which is Sagittarius's brighter stars. Doesn't include all of them. There are considerably more stars in there. In fact, there's another asterism I'll get to when we discuss binocular asterisms. Refers to a spoon that I think is a little bit further to the north and a little bit east of the constellation itself. But there are a couple of others you see I just listed there. I don't want to get too busy with the presentation, but Botes, the ice cream cone, I think everyone's seen that. Moving from Arcturus, moving up to the north, it sort of widens out as you move through the constellation. And basically, it looks like an ice cream cone. And then, of course, here again, a common one that I probably learned before I learned the proper name of the constellation is Cassiopeia. I just knew it as the big W in the sky. And of course, the constellation itself is a lot more than just the W, but more people than not, of course, are familiar with the asterism, the W, because it's the brighter part of the constellation, easy to see, especially with the naked eye. I think that pretty much takes care of my constellation-based and brighter ones, naked eye. Does anybody else have one that they've run across that I didn't necessarily cover or want to make mention of? Anything unique in that respect? Nice and quiet. Okay, we'll move on. Oh yeah, well, there's actually a couple more that I did have. Forgot about these two, and these are pretty common too. Of course, the sickle, which is part of Leo, incorporates the front. I call it the front, but I believe it's probably the more the northern 6 stars in Leo. Regulus, of course, which is the brightest, sitting down at the lower right-hand corner. And then you have the five other stars: Eta, Gamma, Zeta, Mu, and Epsilon Leonis. But then, here again, it outlines the main of the line, but it is a very recognizable asterism because it does look like a hand sickle, with the handle being on the lower part, moving around to the main of the line. Another very common one, and this isn't the only one, but it's probably a principal one, the keystone in Hercules. This is identified with 4 of the principal stars in that constellation: Pi, Eta, Zeta, and Epsilon Hercules, which, if you can follow my cursor, here's Zeta down here, Eta, I think that's Pi, and this must be Epsilon. And of course, Hercules comprises a lot more, and there are some other constellations scattered around, but there are extensions going off Hercules. But pretty much the keystone, and this is the shape of the keystone because the width here is, the top is a little bit wider than the bottom, and pretty much these 2 sides are the same. But of course, this comprises the torso in Hercules. There are other keystones, and I think I might have one later, but of course, this is the largest one. And a keystone shape or pattern is pretty common. And if you spend enough time, you could probably find dozens of keystones in the sky of varying sizes. Some are very small, some are very large. But certainly, when you take a look at these examples and I start to move to the smaller ones, it's very likely that these aren't the only asterisms. There are probably an innumerable number of asterisms in the night sky because it's just a matter of someone taking a group of stars, even if, and still holding to somewhat of a restriction of similar magnitudes, and trying to construct some sort of a pattern. Okay, now we move on. Oh, I still have more additional naked eye. I think I caught just about all of them. A couple that are really a little bit more obscure, and I don't know how many of you are all familiar with the constellations Delphinus, but it lies, a little bit northeast, 11 degrees northeast of Altar of Wheeler. Pretty much it's up in the northwestern sky right now, but it's starting to drop down. But there's an asterism known as Job's Coffin. Delphinus actually comprises, more than 4 stars, but Job's Coffin is pretty much the diamond shape at the one end of the constellation, Alpha, Gamma, Delta, and Zeta Delphini. Don't know what the origin of this one. Similar to a lot of asterisms, they don't really have an origin. So some of them showed up, some do have origins and specifications that may date back a few centuries. But for the most part, a lot of these patterns don't really have a well-documented, or for that matter, any documented history associated with them. A couple of other common ones that are parts here again. A lot of these are parts of constellations, but maybe just a small part. The teaspoon, I made reference to that. That's a few stars in Sagittarius, basically to the, I think the south and a little bit, basically on the handle end of the teapot and a little bit above. But there's basically an asterism that is in the shape of a spoon. Basically, it's a straight line with a curve at the end of that. And of course, that was an easy one that someone looked at to associate with Sagittarius. The water jar, which is the white shape in Aquarius, more or less towards the eastern end of the constellation, at the very top of it. And then, of course, a very common one, of course, this one's somewhat dim and difficult to see, is the circlet, which is the what this would be the southwestern end of the constellation Pisces as it wraps around Pegasus. There's a circlet. Generally, if there's no moon, if you've got some good viewing, these stars are fairly easy to pick out with the naked eye, but they can present a challenge. One of these things, you have to make sure you're night adapted, probably have a little bit better night vision than I do. But for the most part, under good conditions, these constellations, these patterns can be made out. Delphinus is certainly a little bit of a challenge, especially now that the moon's getting closer and closer to full, and it's going to be a lot more of a challenge, especially when it gets down towards the horizon, as it commonly does as we move into the later hours of the evening. Okay, now I think we're moving into the binocular. Here we go. And here I have actually some photos that I took off the web. These are kind of interesting. One called Eddie's Coaster, and this is in Cassiopeia. It's a wave of stars resembling a roller coaster, and you can see pretty much it goes from the top right in the photo that I have here down to the lower left. These are all 7th and 8th magnitude stars. Unless you've got Superman's vision, you probably will not see these, at least being able to pick out the individual stars. You might be able to see a smudge up there, but I will tell you that it is a magnificent sight in binoculars. I've got a pair of 10 by 50s, and it very easily, very readily shows up in those. This asterism is about 3 degrees long, so for the most part, I think the field of vision on my binoculars is just over 6, so it's going to feel almost half the field of view that I have with the binoculars. This asterism lies about 3 or 4 degrees north of Gamma Cassiopeia. And in this particular case, the provenance on this was, an observer. This is a fairly recent one, Eddie Carpenter, looks like associated with the Bristol and Cotswold Astronomical Societies. I'm guessing it's British, but in fact, this is one that's included in the Astronomical League's list of asterisms as far as a program, and I'll get to discussing that later. But this is really kind of a pretty one. In some cases, even though the colors of the stars is probably a little bit exaggerated in this photo, when you look at it, even with binoculars, you can sense a slight difference in some of the colors of these stars. But here again, all similar, about 7 to 8 magnitude stars. Another very common one, and this has been around for a few decades, is Kemble's Cascade in Camillo Pardalis. This was identified by I think it was a Franciscan priest, Father Lucian Kemble, and was put together, has been adopted by a number of people, is shown up in a couple of guides. This is a pretty interesting one of those, I'll call them pretty, because one of the nice things about it, especially when you're looking at a binocular asterism that has about at least 2 or 3 degrees of, in this case, length for these, because these are strings of stars. They show up quite well in binoculars. In some cases, looking at them with a telescope doesn't really do this particular pattern justice because it's just too big for a lot of telescopes. But in this case, here we've got, it's a string of stars running about 2.5 degrees, pretty much in the same alignment as Eddie's coaster does. They're 5th to 9th magnitude stars. So you're seeing a little bit of variation in the stars. And of course, when you look at this particular pattern, you can see where I can get my cursor going. We can pick out some of the 5th magnitudes, the 6th, and then you get down to some of those darker than 9th. This is about 13 degrees north-northeast of Myrfak or Alpha Perseus. But here again, another nice asterism to look at with binoculars. Pretty much I just highlighted a couple of the binocular asterisms that I'm familiar with or seem to have somewhat of a common following. A couple of interesting ones, and this one on the left isn't necessarily real popular as far as I know, but Davis's dog and Taurus, and of course this was submitted a few I think about 15, 20 years ago at the most by Massachusetts observer, probably a amateur astronomer, John Davis. In this case, it's 15 stars. It's in Taurus. It's just a little bit north of Aldebaran. So, and a lot of these stars are pretty bright. And in fact, when you look at the chart, it's just a matter, I think, looking a little bit north of Aldebaran. And pretty much starting at 56 Tauri, which is where my cursor is right now, where this first line points to, is pretty much, oh, I'm sorry, no, this is where I wanted to go. Omega Tauri is the nose of the dog, and that's this brightest star in the lower right-hand portion of the picture, and where I have the arrow pointing from down here. And then pretty much this is the head of the dog. And in the case of 56 Tauri, and there's another star, and I can't remember the number, but pretty much the ears, the front of the dog, the front feet, and then as you move to the rear of the dog, there's actually a system back here, a double, and I think these are the Kappa 1, 2, and Taurus, pretty much define the end of the dog, and then of course we have the tail back here. So this is kind of interesting. When you look at this, unless someone told you it was a dog, I can't imagine that you'd really see it. You might see some other things looking at these stars. Now they're relatively bright. I think they're probably anywhere from 2 to 5, 2 to 5th magnitude for not all the stars, but for pretty much most of the stars. And of course, this is a fairly bright region. There's a lot of bright stars in this area of Taurus. So, but anyhow, it's a very interesting one. And probably one of the oldest and most recognized of binocular level asterisms is the coat hanger in Vulpecula. Prior to this has a little bit of history. This is in the Colander catalog. It is the 399th cluster identified by Mr. Colander out of, I think it's 471 that he specified. And going back, it was also identified, and it was called Brocchi's cluster. And this dates back to just at the end of the first millennium. So this one has a little bit of history associated with it. It's about 8 degrees south of Alberio, the end of the Cygnus constellation. And at one point, a lot of the clusters, for sure the globular clusters, but I think a lot of the open clusters are theorized, and some of them are believed to have an association where they're relatively close to each other and moving in a similar fashion. And for a long time, it was thought that this was also true of this cluster, but shortly after 1970, I think within about 10 years after that, it was pretty much discovered that in this particular case, asterism or cluster, whether you look at it as Colander 399 or you look at it as the coat hanger, that's not true. These stars are not moving together. They are not associated with each other. Maybe one or two of them are, but for the most part, this asterism pattern or grouping of stars is not common. So, and that's true, of course, most of the constellations and most of the patterns are asterisms that we see in the sky. Okay, a few other binocular ones, and I've just listed them here. There are a couple of common ones, but one of the things I wanted to try to point out primarily by selecting these 5 here were the different sources. The home plate in Andromeda, which is 5 stars in a pentagonal shape. It's about basically half a degree, let's say about a third of a degree in area. But one of the common guides, and this is one that's used by the Astronomical League, there's an observer over in, I believe, the Netherlands, de Melzer Ramekers, who compiled a list basically of about, I'm going to say probably 4 dozen asterisms, and has diagrams for most of them. Here again, a lot of them don't necessarily have sources, but this was one. And so when you're looking at these, it's nice to have a diagram to go by so that you could recognize the object in the sky, because sometimes you get just a textual description. It can be kind of difficult. Another one I wanted to point out is the Northern Fly, and this is part of the constellation Aries, basically the northern end, I believe. 35, 39, 41. These are all 4th magnitude stars. It looks like a triangle. No, they call it the Northern Fly. That's fine. I don't know why it got that name, but basically it's just a triangle of stars. But more important, it's about 2 degrees in area. But more importantly, here we have an asterism that was recognized as a different constellation prior to the formal designation of the 88 constellations back in 1928. It was formerly called Musca. Here again, we have a few individuals, Velius in 1690 that specified it. Prior to that, it was known as Apis. And here again, this was an astronomer, I think Doug mentioned in his presentation, Plancius, identified it as Appius in 1612, by Barch as Vespa in 1624. And of course, these are fairly, tight time frames. There was really no standard at that time. So there was really no standard or no governing body, of course, to differentiate with, what was the proper name for a constellation, what comprised them. And even shortly after that, until it was, identified as Musca, Lilium by Royer in 1679, which is a lily flower. And if you look at the constellation Delphinus, you can see it, the stem with the diamond on the end appearing a little bit as a flower. Boomerang and Canis Major. This is fairly bright asterism. It's fairly tight, 8 to 10 stars, 4th to 6th magnitude, basically centered on Delta Canis Major, which is pretty much towards the tail of the dog and a little bit high. But yeah, it looks a little bit like a boomerang, looks more like a semicircle, but fairly bright, wide area. But here again, this is one that was featured in Sky and Telescope back in 2013. And that's how, this one became popular and people started looking at it. The umbrella in Hydra, 7 stars forming basically the canopy, 6 stars forming the stem. A little bit more difficult. These, the magnitude, 8th to 9th magnitude. So only about a degree and a half tall, 9 degrees south of Messier 48. Shiravali, and you'll see the source, I have it at the end. There's actually a book of pattern asterisms, which is probably about the only comprehensive book that I've seen that's been put together on asterisms. Here again, nothing official, nothing standard, but it's been in publication for some time. And I think it's a very common source for a lot of these asterisms. And then here again, something that was specified by an individual, flying the swatter. 5 stars form the swatter, 3 stars form the handle. These are 6th and 7th magnitude stars, fairly large asterism, 2 degrees by 3 degrees. So it takes up a good portion of even at, about, 20 magnification. Here again, and this isn't Upsilon, this is U Hydra, which is about mid Hydra. I think it's about the middle of the constellation and a little bit south is pretty much the fly. So that's what the swatter's hanging over here. But this was submitted by another observer, amateur astronomer, Barb Beaver of the Rancho Bernardo, Murrieta Astronomical Society. So here again, and you'll see a few of these where an individual is responsible for sourcing a couple of these asterisms, not a whole lot. In fact, I think, and there may be others, I know that there's one called Levy 157 that can be attributed to David Levy. Here again, this is a rather small asterism. It is in the Astronomical League's observing program, and I'll make reference to it when I discuss that at the end. Okay, moving to some of the telescopic, and I didn't get into a whole lot of these, but generally when you get into the telescopic, generally they're smaller. The magnitudes are going to be somewhat limiting. Some of these do present a challenge, some not so much. But anyhow, like the Keystone and Cetus, here again, this is a keystone shape, very similar to the keystone shape in Hercules, of course, significantly fainter and much, much smaller. Magnitude 7 and 8 stars. It's only about 105 arc minutes, which is still pretty good size. It's almost a degree across in size. And here again, this is one that's specified in Shiravali's book. But you can see, I provided a diagram of Cetus, and this is where the asterism is located, pretty much where it's located relative to the constellation, still part of the constellation. And this over to the right is the asterism itself. And you can see, the keystone shape of it. And like I say, these are rather faint, but it does provide a little bit of a challenge, especially there are some brighter stars, and it's very, I'll say relatively easy to hop, from one of the bright stars at Cetus to a couple of the others to find the asterism. In this case, as you look at these stars, this is off of a chart, you can see they're fairly bright, so they were somewhat recognizable once it got over the spot. Renault 18, this is another one that's in Rademacher's guide, and I misspelled it, I forgot an A in there, but this is a rather difficult one. I'll beg you to look at it. Magnitude 9, 18 inches in size, 18 arc minutes in size, and it's near Tau Pisces. Supposedly the asterism is meant to show the S shape similar to Superman. If I understand it correctly, basically you have this bright star which is Tau Pisces, but basically, as I understand it, the S runs something like this. But there's no definitive indication to tell me that one way or the other. I could have it upside down for all I know. Probably one of the more distinctive ones, especially out of the telescopics, is 37, which is really a cluster in Orion, NGC 2169. 6th and 7th magnitude stars, fairly bright, especially probably down to, looking at about 70 or 80 magnification. Don't want to get too narrow on it. But in this case, of course, the cluster was identified by Herschel in 1784. When did it become the asterism 37? I couldn't tell you, but it showed up in a number of the guidebooks. But when you look at that, I think you can readily see that the number 37 shows up. Now, one of the nice things about this particular asterism, since it's got a fair amount of detail, is fairly well recognized. It's a great one to show the representation when you're looking at it through a telescope, to tell you what depending on the type of telescope, and how many lenses you have in there and how many turns, but it gives you an idea on how your eyepiece is oriented to a star chart. Where's west, where's north? We know in a lot of cases, you can certainly, put your telescope on a star, whichever, some other object, whichever direction it goes, tries to go out of your eyepiece or out of your scope, that's west. But then it's the matter of trying to figure out, well, is north clockwise or counterclockwise, depending on what type of scope you are. Whereas you can take something like this particular asterism and use it to determine that orientation of your eyepiece, depending what sort of telescope you have, or to confirm maybe your orientation. So I think that's pretty much it. And here's some of these sources. This is Shiravali's book, Pattern Asterisms. I haven't looked at it. I'm not sure what's in there, but I would imagine there's a fair number of them that are used in the Astronomical League's asterism program. Deep Sky Wonders, this is a compendium from Sky and Telescope. A couple of them have, from time to time, Sky and Telescope will have an article or two and will present asterisms. They may associate them with a particular season or just a particular constellation. And of course, the Astronomical League has their asterism observing program. I've been working through that pretty much since May of this last year, a little more than halfway. I've managed to find some asterisms in Cygnus. Believe it or not, they're even near bright stars. They're easy to hop to, but I'm having a heck of a time trying to find them. And this is the guidebook I was talking about from Rademacher's that is one of the reference sources that is used by the Astronomical League. That's it. Questions, comments, anything? Yes, and that does conclude my presentation.
I have a question.
Yes, Kate.
If I were to try and look for this 37
Yes.
in Orion, would it end up being in reverse on my telescope?
I don't know. What do you have?
Well,
I couldn't tell.
I mean, because it seems like a lot of times what I find is, no, I have a Schmidt-Cassegrain 8-inch.
Yeah, because what typically, yeah, it should be upside down and reversed because I have an 8-inch
Okay.
SCG too.
If-
Yeah,
If you have an 8-inch Schmidt-Cassegrain and you
Yeah.
have a diagonal in your, between your eyepiece and your telescope, which most time, I guess you do, right?
yeah.
Yeah, okay. The north and south are going to be correct, but east and west will be flipped.
Yeah, that's what I find.
I think you're going to find your west is counterclockwise from north.
West will be to the right and east to, no, sorry, west will be to the left.
Yep,
and
counterclockwise.
East will
Yeah.
be to the right, but north and south will be correct. North will
Right.
be up, south will be down.
Yeah, that's what I found. Like if I'm like when I'm using,
'Cause that's what my telescope does all the time because I have a
If I'm-
diagonal. If you take the diagonal out, then north and south get flipped.
oh, okay. Well, if I try to look at something terrestrial like Finger Rock, which I can see from my house, it'll be up and down correctly, but it's reversed.
Yeah.
From left to right. So the 37 would be backwards then.
Yes.
You know, some people refer to it as an L and an E too, depending. Here again, if it's flipped up, it'll look more like that, or even a backwards.
Yeah,
If
yeah.
you look at
So-
it, if you look at it upside down, it's an L and an E.
Yeah, and that's why I say in a lot of cases, some of these asterisms, when you start looking at them, you can see the pattern, but you can also see how it can be kind of arbitrary at times, especially since there's no standard for asterisms. And basically, a lot of these have been submitted by individuals, and they've been adopted either into an observing program by the Astronomical League or adopted by the various societies all over the world as part of their programs, or maybe they compile a list for their members to reference.
Yeah, I mean, gosh, anybody could find one and say, this looks like this to me.
Oh, yeah,
Right.
very much so. Oh, and I'm sorry, here's the one thing I didn't have on my references that I used tonight. A couple of pages of those. So yeah, by all means, I've gone through, like I say, how many keystones do you think could be found in the sky by any one of us? Given an hour or two in a good sky. So
I presume the Pleiades are considered an asterism.
They are.
yeah, they are. They're referred to as the Seven Sisters. They're pretty common. I mean, they're definitely a binocular level type, very bright. As far as a particular shape, no, they've been more or less associated just as the Seven Sisters. But here again, it's a cluster based, just like the coat hanger was, and even like the 37. That's a cluster based asterism. Oh, very good. I don't see anything else to chat. Thank you very much for your attention. I appreciate it, folks.
Thank you very much, Peter.
You're welcome.
Good presentation.
Let me stop my share.
With that, I'm also going to end the recording for the night.